Welcome back to Geometry. We are at section 6.7 called Coordinate Proofs. We've seen a few of these problems before, so let's go ahead and just get started. We're being asked to graph ant, which is at 0, 0. So this is point A, and again we're at the origin 0, 0. We're going to go out to 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. And this is going to be point N. And then T is going to be 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Oh, actually, I went up one too many. Let me erase that for us. Let's get rid of that. And let's try that again. 1, 2, 3, 4. Oh, did I go up 6? 1, 2, 3, 4, 5, 6. All right, my eyes are playing tricks on me. Sorry about that. All right, so we're going to draw this triangle. And there it is, and this is point T, and point T is going to be 4, 6. Alright, next it says find the midpoints of each segment of the triangle and label as bug. Alright, let's change colors. So we're going to find the midpoint of AT, and so if I wanted to find the midpoint of AT, I'm going to use our midpoint formula, x1 plus x2 over 2, comma y1 plus y2 over 2. So we end up getting 4 plus 0 over 2, comma 6 plus 0 over 2. That gives me 2, comma 3. And so there's our midpoint. We'll call that B. And then again, we're at 2, comma 3. All right, next we're going to find U. So midpoint of TN. Is going to be 12 over 2, comma 6 over 2, which would be 6, comma 3. And there's U, and we're at 6, comma 3. And then our last point, to find the midpoint of AN, we can actually just count over 1, 2, 3, 4, and there's our midpoint. And so that's going to be point G. And so let's draw this. All right, and so there is our two shapes. Next, we're being asked to find the slopes of AN. So when I think of the slope of AN, I'm looking at a horizontal line. The slope of all lines that are horizontal will always be 0. So I'm going to put in 0 for the slope of AN. So I should also label this as AN. All right, so AN, slope of 0. All right, and then when I look at BU, BU is also going to have a slope of 0, and so we know that these two lines are each parallel because they have the same slope. Now, this goes back to the term midsegments, and we learned that in the previous unit that midsegments will be parallel to the opposite side, okay? And it'll also be 1/2 the length, right? So it's 1/2 the length of the opposite side, and it's also going to be parallel. That was our theorem that we learned about midsegments. All right, next, AN, we found is that. Let's go for AT next. So the line of AT, I'm doing slope, and I rise 1, 2, 3, 4, 5, 6, run 1, 2, 3, 4. Remember to reduce, so even though it's 6 over 4, I have to reduce it to 3/2. And then the slope of UG is also going to be 3/2. All right, rise 3, run 2. So now we have proven that these two lines are both parallel as well. So we've proven that AT is parallel to UG. All right, next we have the line TN. And so the line TN, the slope's going to be negative this time. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So negative 6 over 4, which reduces to negative 3/2. And when we find the slope of GB, rise 3, run 2, we also get negative 3/2. And so this was BG. So we've now shown that BG is parallel to TN. Alright, so what we're trying to do here is we're actually trying to prove that these are mid-segments. Okay, that's what we are showing now. So to show that we have mid-segments, we need two things. We need to show that the lines are each parallel, which we have now done that. Okay, so I'm going to put a check mark here because we have done that. We have shown that these lines are parallel. In fact, I can say AN is parallel to BU. Why? Because they have the same slope as 0. I can say that AT is parallel to UG. Okay, why? Because they have the same slope of 3/2. And then last but not least, I can say that TN is parallel to BG. Why? Because they have the same slope. Okay, so the other thing that'll prove that this is a mid-segment is if the mid-segment is equal to 1/2 the length of the third side. Okay, so I believe that's what we're going to show next. It's asking for the length of AN. So the length of AN, we can just count up 1, 2, 3, 4, 5, 6, 7, 8. The length of BU, 1, 2, 3, 4 is going to be 4. All right, and then the length of TA, we're going to have to use the distance formula. So we're going to take 4 minus 0 squared plus 6 minus 0 squared, and we get 16 plus 36. Remember, this is in the square root. So rad 52 would break down. This would be rad 4 times rad 13. Rad 4 is 2, so we get 2 rad 13. So TA is 2 rad 13. UG is going to be, all right, our point for G was 4 comma 0. So 6 minus 4 squared plus 3 minus 0 squared. That gives us 4 plus 9, which gives me rad 13. All right, well, as I compare 2 rad 13 to rad 13 is 1/2 the amount. So I can say that TA is equal to 1/2 the amount of UG. Okay, and then I can also say that AN is 1/2 the amount of BU. Okay, which is what I needed to prove. I needed to prove that the mid-segment was 1/2 the length of the third side. So we just proved that. Okay, now we also have to do the other side because we have AN, BU, TA, and TG. We didn't prove for TN, but if you look at this next question, what do you think is true about the lengths of the segments TN and BG? Well, TN is going to have a length of 2 rad 13, and BG is going to have a length of rad 13. Now, on a test, you would actually have to show that out, okay? But I'm not going to show it. But if you were to show your work, that's what we would get. So we have now shown that TN is 1/2 the amount of BG. So we have now check marked 2 to show that the mid-segment is equal to 1/2 the length of the third side. All right, then the last thing that we need to show that we have mid-segments, we've already done. Okay, we know that mid-segments will create midpoints. Okay, and we have done that because if you think about the first thing that we did is we found B, U, and G. So since we found B, U, and G, and these were all midpoints that we found, we have now proven all three things that we need to show that B, U, and G are in fact mid-segments. You know, that BU is a mid-segment, BG is a mid-segment, and UG is. So I'm going to go ahead and write the findings. BU, comma UG, comma BG are all mid-segments. Okay, and that's really what this problem was asking us to do. It didn't really say it. You know, there's nowhere where it asks us to prove that really, other than just at the top it says mid-segments. Okay, so we just proved that these three segments are in fact mid-segments. All right, as I scroll down, this problem is actually going to be more challenging than the problem that we just did, and it's going to take a lot more work. All right, let's underline or highlight the text. Use coordinate geometry to prove that the quadrilateral formed by connecting the midpoints of a rhombus form a rectangle. Okay, so the first thing we need to do is we need to find the midpoints of the rhombus. So we're told that in this problem, this shape is a rhombus. So this is what we're given, that let's call this ABCD is a rhombus. Okay, next they want us to find the midpoint. So the midpoint is going to be somewhere right here. And if I find the midpoint of DA, I'm going to say 0 plus 2A over 2, comma 2B plus 0 over 2. And that would give me A, comma B. So I'm going to put A, comma B. Okay, then we're asked to find the midpoint of AB. We're going to get 2A plus 0 over 2, 0 plus negative 2B over 2, and we get A, comma, negative B. Alright, and then we have CB, and find the midpoint of CB, negative 2A plus 2 over 2, comma 0 plus negative 2B over 2. Sorry, this would be negative 2A plus 0. There we go. So that leaves me with negative A, comma negative B. And then our last midpoint, that's going to be CD. So midpoint of CD, negative 2A plus 0 over 2, and then 2B plus 0 over 2. So that leaves us with negative A and then B. Alright, so let's go ahead and draw in this shape. Here's the shape that we have created. Alright, next we need to prove that this new shape that we have drawn is a rectangle. So let's think about how we can prove the shape is a rectangle. Well, if we prove that opposite sides are parallel, and we prove that we also need to prove that there are 4 right angles. Okay, so if we can prove these two things, that opposite sides are parallel in that there are 4 right angles, we also need to show that the opposite sides are each congruent. Okay, so there's really 3 things that we need to do. And actually, if we just show that opposite sides are congruent and that there are 4 right angles, that's pretty much all that we have to do. Okay, but we're going to add in that the opposite sides are parallel because it'll lend itself to proving that there are 4 right angles. So even though we don't have to prove this, I think it'll help us prove there are 4 right angles. So first, let's start with opposite sides being each congruent. Alright, so we can use the distance formula, x2 minus x1. So when I look at, if I look for, let's label these points. So let's call this work. So we have W, O, R, and K. Okay, so if I find the distance of RO, now this is a vertical line, so usually we can just count up, and I'll show you how we can do that after we actually apply the distance formula. So we get A minus A squared plus, and then that's going to be negative B minus B squared, which is going to be 0 plus negative 2B squared, and then that gives me positive 4B squared. And then once I square root this, I end up getting 2B. Okay, now again, this is a lot of work. The way that I could have found this is I can really just subtract b minus negative b, and we get 2b. Okay, but this is a shortcut. We probably didn't see it, so let's stick with our distance formula. Okay, it's much easier when we're dealing with concrete numbers. So if we had 4 and then 6 and then 4 comma negative 3, you know, it's just easier to count up versus using these letters for numbers. All right, so we end up getting RO was 2B. All right, next we want to look at KW. All right, so let's find KW. And to find KW, we have negative A minus negative A squared. And then plus, that's going to be negative B minus B squared. We get 0 plus negative B squared. Sorry, that's 0 plus negative 2B squared, which gives me negative, or sorry, that's going to be positive 4b squared, and then square root that, and we end up getting 2b. Alright, so we also got 2b here. Alright, so I just showed that RO is congruent equal to KW. Okay, so that's one pair of opposite sides. We now have to prove that the other pair is the same. So we're going to find the length of WO. We're going to take negative A minus A squared plus B minus B squared. We get negative 2A squared plus 0. That gives me negative 4A squared. Remember, we have our square root sign, and actually negative squared becomes positive. So we end up getting 2A. So that's the length of WO. Alright, then we're going to find KR. And KR is going to be negative A minus A squared plus negative B minus negative B squared. And that's going to give me negative 2A squared plus 0, which is going to give me 4A squared, which is then going to come out to 2A. So I've now proven that WO is congruent equal to KR because they both have a length of 2A. So let's put marks on this. I've shown this and this. I've also shown that these two sides are each congruent. So I'm halfway there. I've shown that opposite sides are each congruent. Now the last thing I have to show is that we have 4 right angles. So the way that we can prove that is we have to find or prove that WO is perpendicular to KW. And the way that we can show that is we need to look at the slope and see if they have an opposite reciprocal. Alright, so when I look at the slope at WO, this is a horizontal line, which means its slope is 0. Okay, all lines that are horizontal have a slope of 0. If you didn't see that and you used y2 minus y1 over x2 minus x1, you would get 2b minus b over 0 minus, let me do that again. That's incorrect. You would get b minus b over a minus negative a, which would give you 0 over 2a. And 0 over any number would just be 0. Okay, so the slope of WEO, or of WO, is 0. Alright, next we're going to find the slope of KR. And the slope of KR is also going to be 0. Alright, actually, I need to find the slope of KW first. So let's find the slope of KW. And again, this is hard to squeeze everything in, but this takes a lot of work. The slope of KW is undefined because it is a vertical line. And again, to see the work with that, if we were to take let's go y2. So negative b minus b over negative a minus negative a, we would get negative 2b over 0. And when 0 is under, we get undefined. So that's how I got the slope of kw is undefined. And the slope of OR is also going to be undefined. So, all right, when we look at trying to prove that WO is perpendicular to KW, we see that WO has a slope of 0, okay, and we see that KW has a slope of undefined. All right, well, the question that I have for you is 0 and undefined, does this create what's called opposite reciprocals? And the answer to that question is yes. Okay, 0 and undefined are considered opposite reciprocals. You could have 0 over 1, and then you could have negative 1 over 0. Okay, and this is undefined, and this becomes 0 slope. So you can see that 0 and undefined can actually be opposite reciprocals. So as a result, we have proven that these lines are perpendicular, and we can put 90-degree angles in all corners. Okay, so that was a lot of work, but we did show that this shape is in fact a rectangle. Thanks for joining us. See you next time.